voltage drop in my marker. We have different formulas we can use. So ED equals 2 times L times R times I divided by 1,000. So this is a 1 in your book. Then we have ED equals I times R. Okay, the thing with R is we have to find the resistance of that wire. So, because this here is for 1,000 feet. Well, we don't have 1,000 feet. Yesterday I used an example, 2 times 120 times 1.24 times 24 divided by 1,000. And that's what I used yesterday. Here is we have to find the resistance for this 240 feet. Okay. Within the formula, it's already multiplying everything. We have the breaker, it goes, we have our load, and we have a return. Okay, so it's 120 feet there and 120 feet back. That 2 automatically multiplies. So what we have to do is we have to find the resistance of the 240 feet of wire. We have to find the resistance. Here, within this formula, we're getting the resistance and the length. And multiplied by 2 divided by 1,000. But we're also adding the amperage to give us our voltage drop. Okay, so that 24 would go here. So now we have to find R. So we're going to get this. We divide it by 1,000. So basically, is R, to find R, it's 1.24 times 240 divided by 1,000. Okay? The way I did it yesterday is I got this and I divided by 1,000 and I came up with 0.240. Okay? Or 0.0, sorry. That's right. I think this is a calculator just to make sure. 240 divided by 1,000, 0.24. Okay, so now to find that, it's so I already got the 240 divided, so it's 0.24. So it's 0.24. Okay, now I'm just going to multiply. So it equals 2,976. Bring that, now I have R, and that's 0.2976. ED equals 7.1424. I do that up there. Times 120 times 1.24 divided by 1,000. Okay, so this equals ED equals 7.1424. Okay, so I did what the formula in the book does is they're putting it all together so we don't have to worry. Basically they're using this formula, but they're doing this part within the formula. So they're doing this part within the formula. Where do you find it? Right here. There's a 1.24. My distance, well, 2 times 120, that's my 240 divided by 1,000. Okay, then I'm multiplying by 24, which I did right here. Okay, so it's all done in one instead of having to do it separate. That's all that does. That's all that does. Alright, so that's the formula I had done yesterday. And there's other formulas in the book, and the formulas that I gave you, I'm only going to pertain to a couple of them, the ones that would be more useful. If the fan's too loud, I'm sorry. Alright, so in the book we have wire size equals 2 times K times L times I. Again, okay, the formula shows it as a D, same thing, and it's the ED permitted. The ED permitted. The distance or the length, it's all the same. To me, it's all the same. And then we have the other one is ED equals 2. Here it has a circle. That circle tells you K equals 12.9 for copper and 21.2 for aluminum. 2 times K times L times I divided by the C mils of the wire. So this one we use to find voltage drop. This one we use to find wire size. So on the last formula, if I come over here, it would be 2 times 12.9 times my distance was 120 feet, 24 amps, and my voltage drop permitted, I had 120 volts. Times 3%, that was 3.6 volts. Okay? The voltage may change, but that 3% doesn't change. So it may be 120, 240, 277, 480, 532, 536, 600, 1000, it doesn't matter. Okay? From the last breaker to the load, it is 3%. From the So here's my meter for my service. Here's my panel. Here's my breaker. Goes to the load. That's 3%. Now I'm going all the way back from the load to the service. This is 5%. But from the last overcurrent protection device to our load, it is 5%. It is 5%. I do that, 3.6. So here is, I need a wire that's 20,640. I would go to table 8. I would go to table 8. I need a number 6 wire. I need a number 6 wire. We haven't talked about wires, what wire types and everything else, what direct will we use and everything else. We haven't talked wiring yet, we're just talking about a wire size. So I need at least a number 6 wire. I need a number 6 wire. Using this one, when we did that last formula, we came up to 7.1424. If I use this one, voltage drop, okay, if I use that 12.9, 2 times 12.9 times my length times my I divided by the circular mills. So I have number 10, so this is 10 to the 80. This came from table 8. Okay, see. Chapter 9, table 8. Things on page uglies, page 71. Okay, so you got uglies on page 7. Okay, I come here and I do this formula. So 2 times 12.9 times 120 times 24 divided by 10.80 equals. Okay, so my voltage drop here, I put the L instead of the length. So this is 120, this is 24. So my voltage drop is 7.1538. So it's different than we got this answer. Okay. The reason is we're using an approximate. These numbers are approximate. This is for a 500 kc mill wire, a 1,000 kc mill wire. Okay, that's what that's for. That's where they got that from. So in order to get the exact same answer, I have to find exact K. Exact K. K equals R times C mills divided by 1,000. Okay, I have a number 10. 1.24 is my resistance. Okay, we did that in the last one. So for that number 10 wire is 1.24. My C mills is 10 V80. 1.24 times 10.80 equals divided by 1,000. So K equals 12.871. Okay, in order to get the exact same answer that we got last time here, we have to use exact K. Not approximate K, we have to use exact K. That's why these two numbers are off. If you want it to match, you have to use exact K. You notice that this is 12.9. If I got this, I rounded this up to 9, that's where it's at. If you're out in the field, this is all you need. Guess what? It's no different than this. That's hundredths of a percent here. That's nothing. I'm losing twice. Allowable voltage drop is 3.6. I'm losing twice the amount. Okay, so I just make a correction on those size wire, knowing what I got. But if you were taking this test, the first way, the way the book says it, that's the easiest way. This is out in the field. The only reason I'm covering these formulas is if you can't remember that other formula and you open up an Uglies, page 50, the formulas on page 50, which is this one and this one, these are the formulas of the Uglies book. So I'm covering, so if you're ever using the Uglies, now you know where it's at. To get an exact answer to match, to get the exact answer to match, is I got to change K I have to use an exact number. I have to use an exact number, which would be the 12. So it's times 12.87. 12.8712 times 120 times 24. So 12.87 times 2 times 120 times 24 divided by 10, E80, and ED equals 7.1424. So now we have an exact. Now we have an exact. In the PDF file that I uploaded with voltage drop formulas, this is on there. So all you have to do to find the exact K. Here we can use an approximate because we don't know our wire size. We're trying to find a wire size, so we can use an approximate number. We're trying to find a wire size, we can use an approximate number. Okay, if we're trying to find voltage drop in the system, then we need the exact number. So all you have to do is find the resistance of the wire. For number 10 stranded, I think it was 1.24. Yeah. Number 10 stranded, 1.24. The circular mills of the wire is 10 to the 80. I multiplied and divided by 1,000, and I got the 12.87. Okay, so now to find an exact, so now the first time I showed you two ways of doing it, and it's basically the same formula. You're just doing it one time instead of coming to the side. And I came up to the voltage drop of 1.7424. Now I'm showing you a different way. Okay, this one has a circle because that's approximate. This one doesn't have a circle because it is an exact, so you can get the exact. If you're out in the field, guess what? You don't have to use, if you're out in the field, you don't have to use exact K. You can use the approximate K, and it's going to get you within tenths of a hundred, or I mean, whatever's the decimal point. It doesn't matter. It's that whole number you're looking at. It's that whole number you're looking at. So that 7 is more than 3.6. That 7 is more than 3. All I know is I'm losing twice as much. Okay. Voltage drop, again, is not a requirement in the code. Okay. It's not required, something that you have to do. Voltage drop is something you should look at because of efficiencies. Again, which one you use, it's up to you. You know, which one you use is up to you. How you do it, it's up to you. What stays here? What stays here? I can only give you the formulas, and then you use what's easiest for you. All right. I hope this was helpful and help you with your homework. Okay. So again, if you're trying to find the wire size, we can use an approximate. If you're trying to find voltage drop, then you have to have an exact K, or you just can use the formula in your textbook, which is the first formula. And I'll write it down. I will make some of this. So the first formula was EB equals 2 times L times R times. Okay. Which of the formulas you use? What's easiest for you, what sticks on your list. Alright, thank you.